but luckily we still have stuff to do. So determine g of x. So it's been given the derivative here. And if you notice, the derivative is given in a not fully simplified form. There's more math we can do. So the derivative, I'm going to go ahead and simplify. So it's going to be 3x minus 2 times x minus 2. So we're going to have 3 times x squared minus 4x plus 4. So 3x squared minus 12x plus 12. Now that's my derivative. I haven't done any anti-deriving yet. I just simply expanded it so it's going to be easier to do an antiderivative of this. So now we're going to go ahead and solve for capital G of x. So as soon as it's a capital, I know it's my original function. So this is going to be 3. Maybe this will make more sense to you if I do it like this. We're going to simplify that. Yeah. Now remember that this is really 12x to the exponent 0. We don't ever write that, but sometimes that is, if I wrote it down, it just reminds me that it's going to be 12x. That's going to be to the exponent 1. So we're going to tidy that all up. That's going to be x cubed minus 6x squared plus 12x plus c. Forgot my plus c up here. All right, so not done yet. That would have been the answer if I was just doing 36 lessons. So if I was just doing the first lesson, this is where I would have stopped because I didn't have any additional information. What I know now in the question is that g of -1 equals 3. So really what that means is I have a coordinate pair of -1 and positive 3. So again, I'm just going to substitute that into my original equation, and I'm going to solve for the unknown of c. So I'm going to have 3 equals -1 cubed minus 6 times -1 squared plus 12 times -1 plus c. So 3 equals -1 minus 6 minus 12 plus c. We have 3 equals -19 plus c. So I'm going to add 19 to both sides. So I have 21 equals c. So not my answer. The question was to get the equation. So my equation is going to be capital G of x is equal to, so going back up to this line, x cubed minus 6x squared plus 12x plus my constant of 21. So this is what the question was asking for. So not really anything different. It's just getting into the habit of doing that anti-differential. That oh, did you guys notice that 3 plus 19 isn't 21? It should be 22. You're making fun of me, Hall, and I can't add, so it's we're all on the same page. So that should be it. Adding is very important. Okay, so now we're going to take a little bit. We're going to take a little bit of the last chapter, and we're going to add in this chapter as well. Okay, so original function is displacement. You guys know that. First derivative is velocity, second derivative is acceleration. And we know that st would be like the original function, so it's, let's say, speed and time. So velocity is the derivative of speed in relation to time. Acceleration is the derivative of velocity. in relation to time. Sorry, people are texting me for technology help, and I was trying to do my best. Or it's the second level derivative of speed. Those are just all notations of it. Okay, so here's the thing, is that by being given acceleration, we can now find the velocity formula by doing the antiderivative, and so you're working backwards. Normally we went displacement, velocity, acceleration. Now we're going to go backwards, acceleration, velocity, displacement. So determine an expression for the velocity at any time. So any time just means a general equation. And we're given initial velocity of 64 meters per second. All right, are we ready? Okay, so here we go. So we know that acceleration is negative 9.8 meters per second squared. And we know that it's going to be in relation to time because we've got this second squared here, right? So really, acceleration is negative 9.8. Just going to leave the units off for right now. Would be t to the exponent 0, right? We did that before, so that's all good. So let's do velocity. So that means we're going to antiderive this one level. So velocity is going to be the antidifferentiation of the acceleration formula. So that would be negative 9.8 t to the exponent 1 divided by, well, not divided by t, but divided by 1. So my velocity, oh, and I forgot my plus c. So the negative 9.8 t plus a constant. This is where this comes in. That's where it's going to help me solve the constant. So it's v initial. So really that's a coordinate pair. So we know that when time is 0, we have a velocity of 64 meters squared. So my coordinate pair is going to be 0 and 64. So again, hopefully remembering from physics, time is 0. So that means that if I substitute all that information in, 64 equals negative 9.8 times 0 plus c. So c is going to equal 64. So my equation is v equals negative 9.8 t plus 64. So that's the equation of velocity at any time when there's an initial velocity of 64. So that's nice and easy, right? You guys good with that? Sorry, I'm just getting people saying they need my help and then they don't need my help. Okay, so that was part A. Hope everybody got that. Let's scroll back up. Part B. Part B now is saying determine the velocity when t is equal to 3. That's just a nice substitution question. So we're going to have our velocity formula, which is negative 9.8 t plus 64. And we're just going to substitute in 3 for t. Negative 9.8 plus 3 plus 64. Velocity equals 34.6 meters per second. So that's nice and easy, straightforward substitution question. Part C, what does part C say? Determine the expression for displacement. So it's saying that now I have to take the antiderivative of velocity. Because you go in order. You have to do acceleration to velocity to displacement. You cannot jump from acceleration to displacement. You've got to do all the steps. It's like going forward. You can't do the second level derivative. You don't know what the first level derivative is. So part C, okay, part C. So my velocity formula was negative 9.8 t plus 64. So my displacement, that's supposed to be the letter S, by the way. Try that again. S of t is equal to the derivative. I'm just hopping over here. You guys can probably do the derivative. I'll just check in the chat for a second. Ooh. I'm assuming all's good. Nobody else is asking questions. Nihal says yes. Kendra says yes. I'm assuming the rest of you are like, yay, super fun. All right, I'm leaving. I'm going back to teaching. Did you guys fill this in? Did you answer the right? So this means I'm going to have negative 9.8 t squared divided by 2 plus 64 t divided by 1 plus a constant. Okay, so I'm not finished this yet. It says, it also in part C that if the displacement is 16 meters at 0 time, so that's just a coordinate, so it's giving me the coordinate of 0 time and 16. So we're just going to substitute that in. Nothing we haven't done before. So 16 equals a bunch of zeros. So C is equal to 16. That's supposed to be 16. And so my equation is going to be S equals negative 9.8 t squared divided by 2 plus 64t plus 16. So if you're not given that additional information of like that coordinate pair of the original function or of the velocity, then you can only put the c at the end. Because this has given us additional information, we can go ahead and solve it further. And part D is just a simple substitution question again. So for part D, we're looking for when time is 3. So we're just going to substitute that into the equation. So S equals negative 9.8 3 squared divided by 2 plus 64 times 3 plus 16. X is equal to 163.9 meters. And again, this is just displacement, so there's no time in meters. That's nice and easy. So that's a part of the motion question from your application 1. And the next one's going to be a similar. All right. This is exciting. I'm super excited. Okay. So next question or next page, sorry. I feel like we should do more because there's only 3 pages. We usually do 6 or 7 pages. Okay, a ball is thrown vertically upward at 3 meters per second from a height of 2 meters with a constant rate of acceleration of negative 9.8 meters squared or meters per second squared to gravity. Find the expression for the velocity v and height at any time if height is measured from the upward point of projection. Okay, super exciting. So we got a couple of things here. So velocity is obviously velocity. Height, this would be displacement. So you're doing your first and derivative, and you're doing your second level and derivative. Your equation is given right here. That's the equation that you're working on. That's a constant rate of acceleration, so we can actually use that quite a bit to work through a lot of questions. There's some more things up there. So ball is thrown vertically upward. If I look at the units here, that's a velocity, but it's initial velocity. Because we're going to need that. So there's a lot of stuff that I'm pulling from here that maybe didn't pop right off the page. In the last example, I gave it to you piece by piece. In this example, everything's given together. So from a height of 2 meters, so the ball is from vertically upwards, so my initial velocity is 2 meters per second, from a height of 2 meters, that's my starting height. And if you want to link it to a graph, that would be my y-intercept. Which makes sense. If I'm throwing a ball, I'm not throwing it from zero. I think it's zero, letting me line on the ground and throwing it from my ground height. 2 meters seems a little high. I'm definitely not 2 meters, but maybe my arm is up over my head when I'm throwing it. So just some things there. Okay. So when it throws some notation at you, you can like it or you cannot like it, but you should probably see it. So for part A, it says find the expression for velocity. So we know that A is equal to negative 9.8 meters per second squared. That was given. So remember everything off of that. So we want to do the velocity equation. So velocity is equal to the integral, which just means to take the antiderivative. That's all that fancy symbol means. We're going to take the antiderivative of the acceleration as a function. We're deriving it of time. So really what that means is we're going to substitute that in. This is going to be the integral of negative 9.8 of dt. So it's all in relation to time. So this is just telling you right here what variable you're going to use in your velocity and your displacement. So in this case, we're going to use t. Could we have used x? Absolutely. But in this equation, it said t and s and v. So there was no x given to me in the equation. So we're deriving it in relation to time. So that's what that notation would look like. All that means is to do the antiderivative, and the variable I'm using is t. So hopefully that looks terrible, but it's not very terrible. So the antiderivative of this is going to be negative 9.8 t divided by 1. That's supposed to be a 1, not the letter t. Yeah. Plus c. So we have to solve for c now, and it gave us that 3 meters per second as my initial velocity. So my point is 0, 3. So I'm just going to substitute that in. So my velocity is 3, my negative 9.8 times 0 plus c. So 3 is my c. So my velocity is going to be negative 9.8 t plus 3. Okay, that's the first part. So I found my velocity equation. So that's part 1. Part number 1. Good job, everybody. So now we're going to antiderive. We're going to antiderive velocity. So if I was to do that, displacement is s, because that was given to me in the equation. And I'm going to do the antiderivative. So that's my integral symbol. It's like a stretched out s. Velocity, differentiated in respect to time. So this is just telling me what variable is going to be in velocity. Kind of a moot point because, well, I do definitely have a t in velocity, but it did help us in our acceleration question when there was no variable. So we are going to do the displacement, and the derivative velocity is negative 9.8 t plus 3 in respect to time. So hopefully you're all okay with that. That makes sense. So s is equal to negative 9.8 t squared, because I'm increasing my exponent. The exponent and the denominator have to match, plus 3t, because this would have been t to the exponent 0 over 1. Sorry, I'm doing that. Come on, autopilot to me. Plus c. So that's it, but we also have another piece of information from that initial sentence, and it gave us the initial height where we're throwing it from. So at time of 0, I'm throwing from height of 2. So I'm going to substitute that in. So 2 goes there, negative 9.8 squared So my equation would be x equals negative 9.8 t squared divided by 2 plus 3t plus 2. That is part 2. That's part 2 of part A, because it asks for velocity and height. So we did both of those. None of it is terribly difficult math, but it is the math we have to do. And then the question says, when does the ball hit the ground? So this should take you flying back into grade 11, where you learn how to do your quadratic formula. So what we know from this equation here is that that's a quadratic, because it's a square. Okay, so that pops right off the page of the it's going to be a quadratic. So I know a couple things about this graph, if I want to sketch it. I know it's opening down, because it's a negative. I know that it has a y-intercept of 2. And it's going to look something like this. You could find the max height using the first level derivative to find a relative max or an absolute max in this case. But the question is, where does the ball hit the ground? And that has nothing to do with the maximum. That has to do with the zero of the function. Now, as you can see, the function actually has 2, but if this is time, and this is your x, which is your height, this one back here doesn't exist in the real world. Like mathematically it exists, but in the real world it doesn't. So, so I'm going to take my displacement, which is negative 4.9 t squared plus 3t plus 2. None of that I'm going to try to factor. I'm going to use my quadratic formula. That's the 4.9 is just negative 9.8 divided by 2. So I use this in my quadratic formula, as most of you guessed, I've used my A C divided by 2. Ooh, this is lagging today. How great. So I'm going to have an answer. I guess it shouldn't be x, it should be that. It shouldn't be x, it should be t. So we know that it's going to cross the x-axis at 1.0145 and a time of negative 0.4. So right away, I'm going to reject this one, because that's my negative one. We said that that doesn't exist in the real world. So we know that the ball is going to hit the ground. Right, it's going to hit the ground at 1.01 seconds. I'm not going to try to write that in 10 minutes. So that, ladies and gentlemen, is how you find your actual differentiated and differentiated formulas. You have to have that extra piece of information. If you don't, then it is, you can't find it. You just put the C at the end.